All right, Mr. Skinner back here. I welcome you to this video. Now, today we're going to be covering similar figures. They're not exactly the same, but they're pretty close, and we're going to look into exactly what a similar figure is. However, before we do that, we need to do a little bit of review work before we start discussing it. Now, a congruent figure, right here, congruent figure, is a figure that has the same size and same shape. Okay, so they are identical to one another. They are identical to one another. A similar figure is one that has the same shape, but their size is made to be different. So if you look at this one, it's much larger than this one, which is much smaller. Now, this symbol right here is a symbol that means similar. These figures are the same, but they're different sizes, so they are similar figures. Once again, looking back at that original example. Now, the sizes. Although the size of two shapes can be different, there is a factor that will always stay the same. So when we're looking at a factor, what we want to identify is how do you go, for example, from 3 to 6. Now, remember, they have to be the same, so you can't necessarily say, well, plus 3, because in this case, if you look at 2 to 4, that is an addition of 2, not 3. So we can't necessarily use addition, so there has to be something else in this to make it work. Well, if you've noticed, if you multiply by 2, so let me walk over here and get a different color. If you multiply by 2 and you multiply by 2, then you'll notice that both of those will actually work out. So the factor, or scale factor in this case, is a multiplication of 2. This is just an example of a little bit more fine-tuned for what we did. Now, the other thing is you can actually think of this going backwards. So from 2 to 4, you multiplied by 2. But if we're looking at this from the 4's point of view, going from 4 to 2, that would be a reduction of 2 or division of 2. Enlargements. Now, when you have a photograph that is enlarged, you're going to make a similar photograph, but it's just going to be a different size. So what ends up happening is we have this small photograph. We enlarge it by a factor of 3 and end up with what we have here. A reduction. A reduction is a photograph that can also be shrunk to produce a slide. So for example, if I have this very large cutout, I want to make it smaller for probably like a pamphlet or to put into, for example, this presentation. What I do is I ended up reducing that by a division of 4. Now, to determine the length of an unknown side. So what we have here, we have an unknown side. So what I'm going to do is I'm going to grab a different color than what I just chose. And what we want to identify is that, well, if we're looking at this large shape, we have this length and we have this length. Now, we also have this length. Now, we want to kind of identify which sides match with which sides. So because I already have green in my hand, I'm going to go ahead and match it with its corresponding side. Take note, corresponding sides just means it's the same type of side. So the 4 would match with the 12, and the 9 would match with the 3. Now, a couple of things. If you were looking for that factor, the factor will go by a multiplication or a division of a number. So we need to think, how do we go from 3 to 9, or how do we go from 9 to 3? Now, with the arrow going this way, let's take it in the idea of a multiplication of 3. All right, now, we also can look at the 4 to 12, and that 2 should be a multiplication of 3. Now, if we're wanting to look at that 15 to question mark, what we should have is a division of 3 or a division of 3, because we wanted to switch it around. We didn't want to do times because I don't have a number to times it by. So we'll divide by 3, and our answer would be 5. So I'm going to give you a few seconds. You can pause the video right now to give yourself some time to work through this, and I'll end up putting the answer here shortly. The answer is 12 by a multiplication of 12, because if you look from 4 to 24, it is a multiplication of 6, an answer of 12, because if you look from 4 to 24, you multiply by 6. To go from 2 to the question mark, you multiply by 6, and you end up with 12. Just a cleaner version to show you what happened. All right. Now, sometimes the factor between two figures is not obvious, and some calculations are necessary. So here we have a little bit more of a difficult problem. So we would look from 15 to 10. You can do your math on the side, and we can see what we come up with. Now, to find the missing factor, you divide 18 by 12, or you could go in and do 15 by 10, or you could do 12 by 8. All three will get you the same divisor. So 18 divided by 12 is 1.5. Now, if you're looking here, it's asking, if I change the size of a shape, will the angles also change? Now, I apologize for the 40 and the question mark. They should be closer up here in the corners, but they're not for whatever reason. Now, let's think about this. An angle tells us that this distance and this distance should be the same to continue to make the similar shape. All right, so if we're keeping up with the idea that this and this has to be the same number, then you're on the right track. But the question is asking, if we change the size of that angle, or if we change the size of the figure, will the angles be the same? Now, if you keep all of your side lengths within that similar ratio, that similar factor, then what will end up happening is, as long as we keep the same factor, this angle will always be the same. Now, I need to cut this video right here, and I'll start a new one. So please see me at part 2.